Right, so we're going to just do a quick little review of trinomial factoring that you can use to hopefully get through some of the difficulty challenges of factoring trinomials. So I've titled it Trinomial Factoring Three Ways, but there are some other things to consider. Biggest question most students have is, which method of factoring do I use? And the honest answer is, that depends on the expression. And unfortunately, this is the way it's going to work. So first thing you always consider, is there a greatest common factor? If there is, then you must consider removing it out of the expression or factoring it out prior to continuing. If it has only two terms and it doesn't have a greatest common factor, then you'll have to see if it fits a special pattern that is covered in section 4.6. We have to take a look at that. Also, if it has more than two terms, for example, if it has three terms, then it could be a perfect square pattern, which again is going to appear in section 4.6. And if it doesn't fit that, then is the A value equal to 1, making it a simple trinomial, then you can use product and sum technique. If the A value is not equal to 1, then you should also consider a couple of other methods here that you have to take a look at. So one of them being decomposition, another one sum of cross products. But if you've taken a look at the video I've added to your Google Classroom, the bottoms up method will work as well. So I'm going to go through each one of those in a moment. And if it has four terms, you can try factoring by grouping. Now, factoring by grouping isn't covered specifically in any of the video lessons, but I'll show you how it works in the the decomposition technique. Okay. So I've given you an example here, 4x squared minus 16x minus 9. So we'll run through the different possibilities and show you how three methods can be used to factor this, and you have to decide which one is going to work for you. Okay, so the first thing you should note is that the A value in front of the x squared is not equal to 1, and there is no greatest common factor. So there's no factors of 4, 16, and 9 that are the same. So you're left with the option of, let's see here. So A is not equal to 1, making it a complex trinomial. So you can either use decomposition, sum of cross products, or bottoms up. And that's exactly what we're going to do right now. So for decomposition, decomposition involves you examining the A and the C values. So you're trying to set up this little pattern of splitting or decomposing the negative 16x into two terms. So you're trying to find the A and the B here in this pattern and set up a system. Okay, now a system just means two different equations with the same letters in. Should be familiar because we talked about elimination and substitution earlier on in the course. So that's what a system is, just as a reminder. So you have two numbers that have to add to negative 16, but they must multiply to negative 36. Now remember, that's coming from the fact that this is going to be the A value multiplied by the C value. Okay. And since A and B is negative, then A and B should probably have opposite signs. Okay. So you can just run through an entire list if you'd like. You've got a whole listing here, but you have to make sure that in this listing, you have to calculate some of these pairs that are going to fit your requirements. So we're looking at, these are the pairs of numbers that multiply to negative 36. The one that we're looking for to add to negative 16 is right in there. So that's the one we're looking for, right in there. Okay, so the solution we're looking for is the negative 16. So one of the values is negative 18 and the other one is 2. Doesn't matter whether you call it the A or the B, it really doesn't. You can just factor it either way in either case. So you rewrite your expression, decomposing the negative 16x into the two separate terms. The brackets are simply there to maintain focus so that you can do this factoring by grouping now. So you group the first two terms and you group the second two, and that's what I was referring to earlier when I was talking about factoring by grouping right there. So now you have four terms in the expression. Sorry, I jumped ahead a little bit. So you have 4 terms here, 2 and 2 added together. So grouping them just means putting brackets around and identifying 2 of them. And you factor out what's common. So here you have a 2x and a 2x that's common. Here there's nothing really common, so you take out a 1 just so you can identify the next step. So they both have the 2x minus 9 in common. And that's good to know because now the remaining portion, or the remaining factor, will be the 2x plus 1. Okay, so this was the common part. And this is the uncommon part, the remaining factor. And there's your final answer. So that's decomposition. Sum of cross products, not for everyone, but for some students you might like it. Here you have to consider the factors of the 4x squared and the negative 9. So essentially the term with the a and the constant. And what you do is you set up a crossing pattern with the factors. So you look for 2 things that multiply to 4x squared, 2 things that multiply to negative 9, and hopefully when you set this up properly, if it's done properly, and whoops, I gotta move some of these things down a bit. So if it's done properly, then what'll happen is this sum that you get off to the side will equal the middle terms. Let's explain how this works again. So again, factors of 4x squared, 2x, and 2x. Lining them up in a column, factors of negative 9 and 1. Cross multiplying, so 2x times 1 is 2x. 2x times the negative 9 is negative 18x. You add those results together and you're hoping to get the middle term, just like I've got highlighted in color here. And I've set this up intentionally for you to work. So how this eventually gives you the work is you'll get the answers right away. If it doesn't work, then you try rearranging the factors for the 4x squared first, and then try rearranging the factors of the constant to make sure you get this negative 16. So the highlighted parts stay the same. Everything else can change and manipulate. So what you're going to do then is use the rows. Now what I mean by rows is here. So the 2x minus 9 happens to be one of your factors, and the 2x and 1 happens to be the other factor. Now, never a bad idea to put in your signs as well. I'm just going to move that back. So even if you're putting in a positive sign, that way you're clear what you're writing here in terms of the factor. Okay, and that's sum of cross products. Again, not going to work for everybody, but hopefully if you like it, you can use that one. And the last one is probably the strangest of all the techniques. And again, this is not for everybody, so if you don't want to use it, don't use it. Use whichever method you like. This one involves taking the a and the c values to get a new expression. So just to talk about what that means. So you take the a coefficient multiplied by the c value. So the 4 times the negative 9 gives you the negative 36. So what you're doing is you're rewriting it so that the lead coefficient over the a value is a 1. Why do you want to do that? So you turn it into a simple trinomial, and then you can use your product and sum techniques. And that's kind of handy because most students are okay with that. So you want 2 numbers that multiply to negative 36, but add to negative 16. After a little bit of thought and trial and error, these are the pairings that you should come up with. So the 2 numbers that multiply to negative 36, negative 18, and 2, and the same numbers add to negative 16. Here's the weird part. Then you use the negative 18 and the positive 2 to write out the factors in simple trinomial format. You would have the x and the x to begin with, and then you write the values afterwards. So here's the weird part. So not only do you take the negative 18, there's the 18, there's the negative, and the positive 2, oops, just the top part, but then you have to divide both of them by your original a value, which in this case was equal to 4. Up above in the question, there's your a value, 4. And then what you do from there is you simplify your fractions or reduce them. And this is where the term bottoms up comes from. So you take the bottoms or your denominators of each one of these simplified expressions and bring them up and use them as coefficients for the x's. And you notice you get exactly the same result as the other methods. 2x plus 1 and 2x minus 9. All right, so again, you really have to find the technique that's going to work for you. I will post this file for you in the Google Drive for you to read through, and hopefully this video helped you at least get through some more understanding as to working with trinomials. And the only thing you really need to worry about is those special cases from the last section.